Hey everyone, welcome back to my channel. So today we are going to solve an interesting problem. This is the problem of today Leetcode. So the problem name is minimum number of pushes to type word. So now let's go through the description. You are given a string word containing lower English letters. Telephone keypads have keys mapped with a distinct collection of lowercase English letters, which can be used to form words by pushing them. For example, the key 2 is mapped with ABC. We need to push the key one time to type A, two times to type B, and three times to type C. So basically, it's a old phone like we used to have old mobile phones where we have to if we have to type letters we have to double press or triple press the numbers. So next, it is allowed to remap the keys number 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Return the minimum number of pushes needed to type word after remapping. So the problem is, imagine you have an old phone keypad. So each time each key is mapped to collection of letters. For example, the key two is mapped to A B C. So to type A, we press the key once. If you want to type B, we have to press the key two times. Similarly, if you want to type C, then we have to press the key three times. So our goal is to remap these keys to minimize the total number of key presses required to type the type a given word. So that's pretty much it. So now going to example one. So we have word. Let me go through my notes so that I can explain. So the example is A B C D E. One second. Okay. A B C D E. Mm, let me zoom in a little bit. Yeah. Yeah, ABCD. So we have keys from 2, 3, 4, 5, sorry, 5, 6, 7, 8, 9. So these are the keys in keypad that we can remap. So straightforward, if you can see, what we have to do is we can simply assign two first word as key. Other can be anything, and for the key 3 we can assign B. For key 4, we can assign C. For key 5, we can assign E. So other rest can be anything as you can simply consider this. The main important point is we have to assign these in such a way that number of key presses will be minimized. So to at least to press these elements, we need there are five letters in this word, right? So we at least we need five key presses. So this is the minimized answer, because then we can have A B C D E is also there in the word. F, like that we can assign nothing everything else. So the minimized answer is 5. I think you got my point. Yeah. So coming to the next example 3. So here we have the word X, Y, Z. Let me explain. We have the word. mm, Okay. So here we have to count the frequency as well. We have to note down how many times we have to press it, right? X has four four times occurred. Y has occurred also 4 times, and Z is also 4 times. So the So similar to the before example, we can assign x to 2, y to 3, and z to 4. Don't bother about the other letters. Though everything else other than these letters can be assigned to everything other as well. So to press X in the keypad, we have to press one time. So there are four X's in the word. So we have to press 4 times. Similarly for Y, we have to press 4 times. For Z also. So simply we have four. We have to press 4 is 2 12 times we have to press. I think you got the problem. If you not, the next example you will get the clarity. So in third example we have A B Yeah, this is what we have. Let me take the notes. So here, let me count the frequency of each letter. So A has occurred 2 times, B has occurred 2 times, C has occurred 2 times, and D has occurred 2 times. Oh, E has occurred 2 times, F has occurred 2 times, G has occurred 2 times, and H has occurred 2 times. I is okay. One, two, three, four, five, six. I has occurred 6 times. So here is the important. We have around 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 distinct keys. 9 distinct keys. Nine distinct keys. Uh, distinct keys. So we have to map these letters. So we have 8 numbers here to map 9 distinct keys. So how to do it so that the number of places will be minimized. So if you haven't got the idea, first thing we have to do is, so whatever letter occurred more number of times, like I has occurred 6 times, we should try to minimize the number of times we have to press to type the letter I. So first of all, we'll go assign I to the number 2. Let me remove the previous ones. Uh, the I is assigned. So now the everything other elements are of same frequency. So we can simply go assigning each one. A, B, C, D, E, F, F, Z, H. H is okay. So now we have to assign H somewhere. We can simply assign it to 2 itself. H, and the I is already assigned. So we have assigned this. Now analyze the number of presses we have to press. So in order to press I, we can simply click 2 once. So the number of times we have to click is 6 plus everything else is 2 times. Now for A it is 2, for B it takes 2 presses, for C it takes 2 presses. I mean single press only, but since we have uh, 2 times, we have to press 2 times. Two, two plus, and everything else. For H, we have 2 H's in the word. In order to press single H, we have to click 2 times in the keypad. And how many H's we have? 2 H's. So I forgot to add one between. Yeah, that's pretty much it. I hope you have understood the example. If not, please comment in the videos so that I'll try to improve my explanation. So now, after, let me analyze this how we have solved this. I mean, without using any algorithm, we try to first of all we try to count the frequency of each letter in the string given, and then we have identified the number of distinct keys so that we have to assign the numbers here. And here we have 1, 2, 3, 4, 5, 6, 7, 8. So 8, we have 8 keys in the mobile telephone that we can reassign with any letters we want. So how to solve this? Let me write a I'll go for this. So first of all, I count the, let me write it as steps wise. Go through the letters in input string and then count the frequency of letters in string. Okay. uh, letters in string. What's the next thing? After counting the frequency, we have to sort uh, sort them according to the frequency. Why? Because so that the highest frequency letter can be uh, typed using the single press, and then a double press, and then triple press, or as long as the words letters keep going on. So that's the main problem. And then fourth one is, after frequency, calculate the number of presses needed and return it. Yeah, now let's go to the the lead code and start coding. So first of all, we have to count the frequency. To count the frequency, I'm declaring a map of type character, and integer. Integer. And I think we could call it frequency. Mm, and okay, go through the characters of the string. See word dot. Now it's the word is a string, so we have to convert it to char array, uh, so that we get the array of characters. And now each character we have to. So I what I do is, if the frequency frequency dot contains key C, we can increment the frequency. Frequency dot put C comma frequency dot let whatever the previous frequency is, will simply increment by one. And if the hash map that doesn't contain the frequency of that, doesn't contain the character, then we can simply put initiate the frequency as one. There is a simple way to do it as well, using the add or default. I prefer to do this way. So now we have got the frequency of each character. Now the next we have to do is uh, we have to sort the frequencies. As I have discussed before, also I have explained before, why do we have to sort this uh, frequencies. That's because so that letter which has occurred, which has frequency more than others, so it can be typed with a single click. So that's how you minimize the number of presses needed. So in order to um, get the maximum frequency first, I'm going to use hash map. It is your wish if you want to use something else, or address dot sort. Anyway, I'm going to use priority queue here. So I'm gonna declare a priority queue. Priority queue of type integer. Continue. Queue. So on one more thing, so the by default in Java, priority queue returns in pops elements in ascending order. That is, the least number we get first, and then gradually get to. So what here we want is, we want the greatest number first. So we have to use lambda function to reverse the order. So we can simply add it like this. B minus A, that reverses the order. If you don't know about lambda function, then you can go and check out in YouTube, which is very good to know this concept. Yeah. Now we have created the priority queue. Now let me add the values of the hash map to the priority queue. PQ dot add. Where since we are going to add a set of array of values, I'm going to add all. And there is a function to get values from hash map, so I'm going to use that function. Simply add dot values. This it will return all the values. Now we got the frequency in the order we want, a descending order. So now what we have to do is simply calculate the number of presses it requires. So I'm going to initiate a while loop while the frequency, the priority queue is empty. Using the is empty function, uh, the loop will run until PQ is empty. So let me initiate a answer okay. Int answer, that is a minimum number of presses. Initiate it with 0, and so simply answer is going to be uh, also initiate index, so 0, so that we also have the count of the number of characters. So index, we have eight what two, we have 8 keys in telephone. So for the first 8 digits, for the first 8 digit we have to press one time only. For the next set of 8 digits, we have 8 letters, we have to press key 2 times. So with this logic, what we can add is, so index divided by, we have 8 keys, right? So plus 1, because if the suppose index is 1, then 1 by 8 gives us 0. If we multiply 0 with the number of places we need, we won't get the answer. That's why we're adding 1. And pop the element from the priority queue, so we do not use it again. So there is a function called poll, which returns and also removes the element from priority queue. Yeah, and then increase the index. That's all. That's pretty much it. Now we have to return the total number of minimum number of key presses. I hope this works. We got the, yeah, okay, simple printing, typing mistake. It's fine. Yeah, it worked. Let me submit the answer. Yeah, we got it. Beats 8%. Yeah, okay. There might be some ways to minimize the time complexity as well. So let's analyze the time complexity and space complexity. First of all, going through the each character of the word using a for loop, and then we are using a priority queue, which is frequencies. Okay, then a while loop. So the time complex will be O of n, whatever the is the size of word, because the only time we are iterating in the first loop, we are iterating through every character in the word, and then next here creating priority queue. These are all just O of 1 operations, because in lowercase letters we have just 26 letters, I guess. Of course, it's a fact. We're just looping through that, so it will be a constant. So the time complexity will be O of n. And coming to space complexity, so we have created a map. So simply, the map will be having at max the size of 26, the amount of letters we have in English. So this can be considered O of n because it is a constant. And then similarly for the priority queue also, this will maximum will have the size of 26, which is also constant. So the time complexity is O of n and space complexity is O of 1, which is constant. Okay, bye guys.